Here let's discuss some of the important problems on central limit theorem, and this is the part 1. If you like my content, please do subscribe to my channel. The very first important problem we have, the mean height of the students in a college is 155 centimeter and standard deviation is 15. What is the probability that mean height of 36 students is less than 157 centimeter? So first write the given information. The mean height of the students in a college is 155 centimeter. So that means mu is equals to 155 centimeter and the standard deviation is 15. So sigma is equals to 15. And what is the probability that mean height of 36 students? So 36 is the sample size. So n is equals to 36. Now by the central limit theorem, we have the formula z is equals to x bar minus mu by sigma by root n. So substitute the values here. That equals to the 157, nothing but the mean height of the 36 students is less than 157 centimeter. So mean height, that is x bar, that is 157 minus the mean population, mean is equals to 155 and divided by the standard deviation is 15 divided by root of n is 36. Now 157 minus 155 is 2 and divided by 15 by root 36, nothing but it is 6. So that equals to 2 into 6 by 15. So when I write like this, 2 by 1, it can also be written as 2 by 1 divided by 15 by 6. So it means we can also write it as 2 by 1 into 6 by 15. So that equals to 2 into 6 divided by 15. Now 2 into 6 is 12 divided by 15. So this value comes as 0.8. So this is the value of z. Now we have to find out the probability that mean height of 36 students is less than 157 centimeter. So probability we have to find out. Now the probability x is less than 157 because they given it as the mean height of 36 students is less than the 157 centimeter. So we have to write it as probability of x less than 157. So that equals to probability of z less than the z1 value. That is, if z is positive, or we can also say it as z1 is greater than 0, then probability of z less than 157 is equals to 0.5 plus area of z1. So here when the z is less than z1, I'll write here, when z is less than z1, we will have the two cases. Either z1 can be greater than 0, nothing but it can be positive, or z1 is less than 0, nothing but the z1 value is negative. So we will have the two cases. But when you see the z1 value here, it is 0.8. So 0.8, nothing but it is a positive value. So if z1 is positive, nothing but the z1 value is greater than 0, then the formula we will use is probability of z less than z1 is equals to 0.5 plus area of z1. So this is the formula we will use. So here the z1 value, nothing but it is the 157. So the formula is probability of z less than 157 is equals to 0.5 plus area of z1. Now that equals to 0.5 plus area of the z1. Area of z1, nothing but it is the z1 value is 0.8. So 0.5 plus from the table we have to check the area of 0.8. So from this the table, the 0.8 is here on the first column. We have to check the 0.8. So 0.8 can also be written as 0.80. So the first column is 0.00. When you add this 0.8 and 0.00, it comes as 0.80 and that is same as the 0.8. So here the z-score is given as 0.8. Now you have to find out the area of this for the z-score 0.8. So from this the column, the 0.8 is here and this is the from the second column, and from this horizontal row the value is 0.2881. So this is the area when the z-score is 0.8. So here write the value 0.2881. So when you add this value, then you will get 0.788 and this is the probability. So the second problem is A random sample of size 100 is taken from an infinite population having the mean mu is 76 and the sigma square is equals to 256. So what is the probability of x bar between 75 and 78? So here the given information, the sample of size 100, nothing but the sample size which is represented with a small n, that is given as 100, and this is taken from the infinite population and that population mean is 76. So population mean, that means mu is equals to 76 and the sigma square is equals to 256. So sigma square nothing but it is the variance. So variance is given as 256. Now when we use the central limit theorem, we will have only the population mean and the mean, standard deviation, and then we'll have the sample size. So the variance is given. Now to get the standard deviation, we will do the square of the variance. So standard deviation is equals to square root of variance. So standard deviation is equals to square root of variance, nothing but it is represented with the sigma square. So when I square this, square and root will get cancelled. So standard deviation becomes sigma. Now the same here, the standard deviation is equals to root of sigma square, that equals to sigma. Just you have to do the square root to the variance value. So square root of 256 nothing but it is a 16. So standard deviation sigma is equals to 16. Now by the central limit theorem, we have the formula z is equals to x bar minus mu by sigma by root n. So here they given that the probability of x bar is lying between the 75 and 78. So you have to find out the probability for 75 less than x bar less than 78. Now here the by central limit theorem we have the formula. So first when x1 bar is equals to 75, when x1 bar is 75, then we have to substitute the x bar value, that is 75, in the formula. So z1 is equals to x bar minus mu by sigma by root n. You can also take it as x1 bar. Now when I substitute the x1 bar value, that is 75, I get it as 75 minus, and the mu is 76, divided by the sigma is 16 and divided by root of n, nothing but it is 100. Now 75 minus 76 is minus 1, divided by 16 by the root 100 value is 10. Now when I take this into the numerator, it multiplies with the minus 1, so it becomes minus 10 by 60. Now this value comes it as minus 0.625. So this is the z value when I substitute the x1, nothing but x value, as 75. So I can take it as z1 is equals to minus 0.625. So here I took z1 because the next step we should also substitute the 78 value in the place of x bar. So when I substitute the 75, I got the z1 value as minus 0.625. Now I should also substitute the 78 in the central limit theorem formula. So when x2 bar is equals to 78, so z2 is equals to x2 bar minus mu by sigma by root n. So that equals to, substitute the values, 78 minus the mean is 76 divided by sigma is 16 and divided by root of sample size, and nothing but it is 100. So that comes as 78 minus 76 is 2 and divided by 16 and divided by root of 100, nothing but it is 10. Now this when it goes to the numerator, it multiplies with the 2. So 2 into 10 is 20 and divided by 16. So 20 divided by 16 is 1.25. So this is the z2 value. So whenever the x1 value is 75, then z1 is minus 0.625. Now whenever the x2 value is 78, the z2 value is 1.25. Now we got the z1 and z2 values. Now we have to find out the probability. So the z2 value is 1.25. Now in the first, the z1 value I got it as minus 0.625 and the z2 value I got it as 1.25. Now the z1 value is minus 0.625, which means it is the negative value. So negative value nothing but it is the z1 value is less than 0, and the z2 value I got it as a positive 1.25, nothing but it is a positive value, so it is z2 greater than 0. Now the z1 is less than 0 and z2 is greater than 0. So at that time we have the formula to find out the probability, which we already discussed in the previous class. So that is, the probability of z1 less than z less than z2 is the modulus of area of z2 plus area of z1. So this is the formula we will use when the z1 value is less than 0 and z2 value is greater than 0. So here we are taking the modulus because the probability cannot be negative, and when we are also taking the area of the z score, at that time also we cannot take it as negative because area cannot be negative. Now here the z1 and z2 values are 75 and 78. So probability of 75 less than z less than 78. So we can also take these as the x values. So initially we took x1 bar and this one was the x2 bar. So we can also take it as probability of x1 bar less than x less than x2 bar. So this is same as the previous. We can also substitute the z1 and z2 values here. So at that time the probability will be, by using the formula, modulus of area of z2, that is 1.25, plus area of the z1 is minus 0.625. So you can take only two digits because we are finding out the area from the ND table. Now we have to find out the area when the z score is 1.25 and when the z score is 0.62. So from the table, first take the 1.25. So 1.25 nothing but from the first column, these are all the z scores. So search the 1.2. Now when I add 1.2 plus 0.05, which I get it as 1.25. So from the first row search the 1.2 and from this row search the 0.05. So when I add this 1.2 and 0.005, I get it as 1.25. Now here the 1.2 and the 0.5 is here. So this is a column and this is a row. This value I got it as 0.3944. So this is the area when the z score is 1.25. So it is 0.3944. So area of 1.25 is 0.3944 plus the area of 0.62. Now from the first column take the 0.6 and from this first row take 0.02. So as we have the 0.62, this means 0.6 plus 0.02. So when I add these two, again I get back the 0.62. So from here it is 0.6 and this is a 0.02. So this value is 0.2324. So this is the area when the z score is 0.62. So 0.2324. Now we got the areas for the respective z scores. So when I add these two areas, I get it as 0.6268. So this is the probability. Now this problem is very important, which can be asked directly for the 10 marks, and the similar problems also can be asked. So this is said to be one of the important for the SEM exam. Now the third problem, we have a normal population have a mean of 0.1 and the standard deviation is 2.1. Find the probability that mean of a sample of size 900 will be negative. So the population mean is 0.1 and the standard deviation is 2.1. So we have to find out the probability that the mean of the sample size is 900 will be negative. So first, population mean mu is equals to 0.1 and the standard deviation is equals to sigma, that is 2.1, and the sample size n is equals to given as 900. Now by the central limit theorem we have the formula z is equals to x bar minus mu by sigma by root n. So we don't know the x bar value. The x bar value is didn't give in the problem. So first substitute the remaining values. So x bar minus the mu is 0.1 and divided by sigma is 2.1. divided by the root of n, nothing but root of 900. So x bar minus 0.1 divided by the 2.1 by the root of 900, nothing but it is 30. So that equals to x bar minus 0.1 and the divided by 2.1 divided by 30 is 0.07. So this is the z. Z is equals to x bar minus 0.1 by 0.07. So that is here z is equals to x bar minus 0.1 by 0.07. Now from this the 0.07 I want multiply with the z. Now it can be written as x bar minus 0.1 is equals to 0.07 into this z. So send minus 0.1 to the right hand side. So it becomes positive. X bar is equals to 0.1 plus 0.07 of z. Now the probability sample mean will be negative. Nothing but let us assume that the sample mean is negative. In the problem they give it as you find the probability that the mean of a sample of size 900 will be negative. So for the negative we have to find out the probability. Nothing but here the probability, nothing but p of the sample mean is represented as x bar and it will be negative. Nothing but it will be less than 0. So for this you have to find out the probability. Now that is probability of x bar less than 0 is equals to probability of the x bar. Here we got it as 0.1 plus 0.07 into z. So just write this value in place of x bar. So 0.1 plus 0.07 into z and the same less than 0. Now 0.1 sent to the right hand side. Nothing but this is also a symbol. Now when you send this to the right hand side it becomes negative. So 0.07 into z less than minus 0.1. Now send also this 0.07 onto the right hand side. So here it is multiplying with the z. When it goes to the right hand side it will be divided. Nothing but probability of z less than minus 0.1 divided by the 0.07. Now minus 0.1 divided by 0.07 value is minus 1.428. You can also do in the calculating. So probability of z less than minus 1.428. Now for this we have to find out the probability. Now let us take this minus 1.428 as the z1 value. Let us assume, because in the starting we didn't get the value of z because they didn't give the x bar value. So from here the value we got it as minus 1.428. So this value is the z1. Now probability of z less than z1, if z1 less than 0 or z1 is negative, then we have the formula. So here the same concept, when z is less than z1 we will have the two cases. Either z1 can be negative or greater than 0, nothing but it can be positive, or it can be negative, it means less than 0. But here the value of z1 is, here I write the z1 is equals to minus 1.428. So minus 1.428 nothing but it is a negative value, which means z1 is less than 0. So for z1 less than 0 we have one formula, and for z1 greater than 0 we have the one more formula. So here when z1 is less than 0 or z1 is greater negative, so at the time the probability of z less than z1 is equals to 0.5 minus area of z1. So this is a formula we will use. So 0.5 minus area of the z1 value, nothing but it is 1.428. You can also write the minus 1.42, because from the ND table we will have only up to the 2 digits after the pointer. So from the ND table you have to find out the area when the z score is 1.42. You should not multiply this minus with this, because just this minus we took only to check whether the z1 value is less than 0 or it is greater than 0. So just to know that we have taken the negative, this sign, but you should not multiply with this minus. Now you have to find out the area for 1.42. So from the table, so 1.42 nothing but it is 1.4 plus 0.02. So when you add 1.4 and 0.02 you will get it as 1.42. Now from this z score take the 1.4. So 1.4 is here, and from this first row take the 0.02. So this is the 0.02, and from this first column it is the 1.4. So 1.4, and from this row the value is 0.422, 0.4222. So this is the area when the Z score is 1.42. Now write the value here. It is 0.4 in 422. So 0.5 minus the area of 1.42 is 0.4322. Now subtract the 0.4322 from the 0.5. You will get it as 0.9778. So this is the probability when the sample size of 900 will be negative. So these problems are very important, which can be asked directly for the 10 marks, and we'll also have the part 2 in the next section. And if you have any doubts, then let me know in the comments.